We got a number theory combinatorics combo episode, and I think you're really going to enjoy it. How many factors of 12 factorial are not perfect squares? So try it on your own, or you could just watch me solve it. Okay, so in order for a number to be a perfect square, if we write out the number in its prime factorization, each exponent is going to be even. Okay, so let's write out the prime factorization of 12 factorial. Okay, and so 12 factorial is equal to, well, how many times does 2 divide into 12 factorial? Well, 2, it'd be each even number contribute to 2. So that's how many evens are there? The floor of 12 over 2. But numbers divisible by 4 contribute an extra factor of 2. So that's the floor of 12 over 4. And then similarly, each factor of 8, each number that's divisible by 8 contributes even another factor. Okay, so this is the exponent of 2 in the prime factorization of 12 factorial. Okay, let's do the same thing with 3, and we'll do it for each prime. So the exponent of 3 is 12 over 3 plus the floor of 12 over 9. That's a floor. Okay, what about 5? That's the floor of 12 over 5 plus the floor of 12 over 25, which is 0. Okay, so we'll just do all these here. 7 is the same idea. Maybe I could draw that like an adult and not like a child. Now that is a 7. Okay. Floor of 12 sevenths. And then 11 is the floor of 12 elevenths. Okay. So putting this all together, 12 factorial is equal to 2 to the 6 plus 3 plus 1 is 10 power times 3 to the 4 plus 1, which is 5 power, times 5 to the 2, times 7 to the first, times 11 to the first. Okay, why did we do that? Now it's going to be easy to count the total number of factors of 12 factorial. Okay? Because any factor of 12 factorial has an exponent of 2 between 0 and 10, has an exponent of 3 between 0 and 5, has an exponent of 5 between 0 and 2, and then either has 0 or 1 for the exponent of 7, and 0 or 1 for the exponent of 11. So the total number of factors, this is not the answer, but this is just the total number of factors Okay, how many options are there for the exponent of 2? It could be 0, 1, 2, all the way up to 10. You could count, that's 11 options. How many options are there for the exponent of 3? There's 6, right? It's 1, 2, 3, 4, 5, or 0. Okay, so the total number of factors of 12 factorial is 792. And what we want to do is count how many of these factors are not perfect squares. Another way to say that is how many of these factors have a prime factorization where at least one of the prime exponents is odd. Okay? So another way to answer that, so we want to count the number that have at least one. So let's write that down. We want to count the number with at least one odd exponent. Right? That's what the question is asking us to count. But that's equal to total minus only even exponents. right? So the total with at least one odd is all of the numbers minus the ones that have no odds. And that's easier to count. So let's count how many only have even exponents. Okay, how many options are there for even? Well, the exponent of 2 could be 0, 2, 4, 6, 8, or 10. That's 6 options. The exponent of 3 could be 0, 2, or 4, right? We need the exponent to be less than 5 and even. That's 3 options. The exponent of 5 could be 0 or 2. That's 2 options. The exponent of 7 has to be 0, right? If it's 1, then it's odd. So there's only one option, and similarly with 11. Okay, and so that's equal to 36. So to answer our question, how many factors of 12 factorial are not perfect squares? That's 792 minus 36, which is 756. So let me know what you think. A little number theory, a little combinatorics. I thought it was a neat question. I'll see you later.